There is a trend happening right now in the world of technology. It's been coming for quite some time. We've got this huge amount of data that's being recorded on everybody, on your cell phones. Everywhere you go, you touch a device that records some amount of data on you.
We are using deep learning techniques to predict the default rate of borrowers all over the world. So machine learning is the art of extracting information out of data. And what you want out of your data, that's given by the human. So the human has to decide, okay, I'm going to find outliers, or I'm going to find who I should sell this product to. And this information is hidden in the data if you have good data. So the art is to, assuming you have reasonably good data, to extract that knowledge. And you don't do that by looking at the data by hand or by eye anymore, as it used to be in the past. You're doing this with a machine. That's why it's called machine learning. It's computers that you say, here, go at this data and tell me what I want to know. The typical applications of machine learning in the current economy is lead scoring, where you want to find out your potential customers. Who should I sell this product to? Or who should I target? You can literally rank your customers and say, this guy I need to call right now, because the chances of him buying or her is like 85%, given the data that I have. And that might be surprising to you, because looking at that customer, you would not have figured that out by just guessing, by human estimates, right? That this should be a good one. That's very hard to do for humans, because they don't see all these different factors.
Artificial intelligence is the idea that we can automate or create a machine that can do what we do. And that's generally what we've been trying to do with computers from the very start. Now, something weird happened, and we created a machine that was actually better than us at what it did. You know, it was way better. In fact, it was amazing, so amazingly better that it's changed our whole society and our whole world. It's getting closer and closer, I think, now to what we kind of envision as the future of artificial intelligence. And that is machines that can actually do the kinds of things that we do. You know, we have been better than it so far. We've been better at doing things like art and doing things like predicting the future.
When I was at Intel, we created the front end of the microprocessor that ran at 1/18th the energy. That's 1/18. In terms of how this technology relates to particular applications, and in particular, you know, very complicated and, you know, more challenging applications such as artificial intelligence. I mean, these sort of algorithms are ones, again, that don't map very well to the traditional way that we've done things in the past. All of these artificial intelligence tend to be more like biological systems than than these traditional computer systems that we build. So our circuits actually map very well to algorithms. And in fact, in many ways, is the way we build systems in hardware is more like the way algorithms, such as artificial intelligence algorithms are built. We have components that we build that plug together that can operate at dynamic frequencies based on the data that you're feeding it, the frequency, and the complexity of the data that you give it. So they can dynamically adapt to both the environment and the data being fed into the system. The benefit of that, again, is typically performance, energy consumption, and area. So we're much more efficient because of that more unified mapping of how things are done.
So machine learning has changed a lot in recent years. 5 or 10 years ago, everybody was talking about support vector machines, logistic regression, random forests maybe, but not many people were talking about deep learning, like neural nets, very deep neural nets, gradient boosting machines, ensembles, automatic feature selection, automatic parameter selection. All that stuff is happening nowadays. There have been many algorithmic improvements recently, such as deep learning, that was finally able to solve problems that were not possible before. So deep learning has evolved so much that you can just click a button and say go, and it will just work. And in the past, you would have to tune 20 different parameters, and you would not know what's going to happen until you figured it all out for this one data set. It was too much work. So algorithmic advances have made it possible, but also computers have gotten so much faster. Just for example, GPUs they have so much computing power that, or clusters of Hadoop clusters nowadays in every company, you can compute so much more than before that you can unleash a whole set of models onto a data set. You don't have to build one model, you can build 50 models and make an ensemble out of those. By applying these brand new algorithms that are deep neural networks with hundreds of input features and tens of thousands of neurons inside that lead to millions of weights that are learned just like a human brain. Like every single connection in our brain is represented by this neural net model as a bunch of weights that are being learned from the data. So the more data you throw at this model, the better that gets, and it will be able to just learn all about predicting default rates. That's what it does. This little brain in this system does nothing else but predicting default rates for borrowers.
Well, it's all about context, being able to do any kind of analytics, any kind of predictive analytics, trying to figure out predict what's going to happen, right? So what is this person going to do? Are they going to default or not? That's the real question. And there's a scale or there's a risk factor. So that kind of, that's the end product. So you want to gather, I mean, if you just think about, like, if I was to go down and try to do this manually, what I would do as a human being instead of an automated program, I would go down and I would find out as much as I possibly could about the person. I would find out, what kind of a family do they live in. I would do an interview with them, and then I would make a prediction based upon that information on what I think is going to happen. So big data and AI is all about automating that process.
So all kinds of data can be used to predict human behavior. You can collect when they last bought something, how much they paid for it, where they paid for it, what they bought before that. I can do all kinds of time series. You can say what they tweeted at that time when they bought it. You can look at social media. You can collect all kinds of data together into an amalgamate of data, where in the end you have so much available data that the algorithm will decide what's good for it and not the human. In the past, the human would decide and say, okay, I'll need this feature and this feature and this feature, and that's it. But now, with machine learning, you can just collect everything, and the machine will tell you what actually works and what doesn't. And it's often surprising to the human that something happens. So there's 3 things you need to gain a competitive advantage with machine learning, especially if you want to predict borrowers' default rates, for example. You need better data, a better model, and to know what to do with the insights gained from that model. So better data is always better. There's never a case where you have a problem by gaining more data or better data that of course works in conjunction with the model. So the model has to be able to suck in that data to gain from it. But that is easy to measure. All these models have a metric associated with it. You can tell whether the model actually is better than another model. So once you have good data and your model predicts better on holdout data, you can tell for sure that you have a good system. And now you just need to act on those insights. So the model will make predictions, will say this person will have this default rate, this person will have that default rate. And now what? Now you need to act on it. And once you do that, then you get your money.
Today, with a combination of deep learning, data science, artificial intelligence, and Bitcoin, and what's happening in the microprocessing world with computer chips, we have the ability to bring commerce and access to world markets and access to capital to these currently unbanked.